This is part 3 of making a radius turning tool, and I hope that we'll get back to the machinist jack soon. In this video I need to put right a mistake from the previous video. I don't know what I was thinking when I drew up the split nut. There's a little tiny 3mm screw that goes in there, and the idea is that it was to clamp that up and tighten on the thread. But there's no way that that is going to bend that section. That's just totally unrealistic. What I should have done is to relief this side here and maybe put some additional cuts here as per this modified drawing. So what we need to do is drill in position here this hole, and then continue the slitting saw through into that, and additionally a couple of slots from the outside, and those slots from the outside will just clear the shoulder, so they'll come into sort of that position. So over to the mill to set this up, first of all aligning this with the axis of the machine, picking up on the diameter and drilling that hole. So I need to sit the component on this little disc I've got here so I don't go into the table, and also I've got adequate support. I used a ruler which fitted nicely in the existing slot to align the slot with the axis of the table. Again, the ruler came in handy for lining up the slot with the slitting saw to extend that slot through to the other side. Let's just see if that's cut all the way through. Oh, it has. Great. So here's the modified drawing for the base. We need to add this hole, and I put the critical dimensions on there from the diameter to this center line and from the end to this center line. We're going to first need to just mill a flat in there so we can drill right through, and it goes in that direction. Okay, I've touched off from this corner, and in fact I did measure not from the outer diameter but from that corner. That's what I've shown on the drawing, and just to double check that I am indeed cutting the slot on the right side. It's very easy to make mistakes like this. Here is the split nut, so that's correct. Okay, quick transfer to my pillar drill, and I've picked up that center, so hopefully we can drill that through now. Okay, time to see if this all fits together. Of course, I've given everything a thorough clean and deburr, especially that hole. Now this is the crucial bit. Does that line up? Yes, it does. Good. So now we can control the clearance and achieve, hopefully, a little turntable that doesn't have any slack in it. Seems like you need to nip it up slightly just to partially grip the thread and then finalize it. That's a bit too tight. Yeah, that feels nice. So the turntable is now completed and we can move on to the turret that sits on top of this. The next item to work on is this bracket that sits on top of the table. So I have a detailed drawing here. It's just 1/2 inch thick by 1.5 long by 3/4 of an inch high, and the piece of stock I've got is here. I've just cleaned it up a bit, got rid of some of the rust, and I'm going to put that in the milling machine. And I think the first thing we're going to do is cut this profile and the slot. Okay, I've got the bracket set up now in my vise. It's square vertically and it's square in this axis. I've touched off on this face and moved across to the correct position for the center line of the two holes, and also off this face as well. This needs to be spot faced. Originally I was not going to put this curved feature in, but I've made it that way, so I need to spot face it and then center drill the two holes and then take it over to the drill for drilling out. So back to the drill to open out the center drilled hole for an M5 thread, and this is where the tool holder will bolt to the bracket. This tapered relief isn't for cosmetic purposes, it actually extends the diameter of the ball that can be turned. So if you look at the layout drawing, this is necessary for turning a 2-inch diameter sphere. At last I can chop off the bracket from the extra stock. The extra material is no longer required for work holding. I've set up the bracket on a small angle plate and I've dialed it in this way. It's only a short face, but I think that's sufficiently accurate to make sure that I'm cutting this square. And I need to reduce this to 1/4 inch thickness. So I'll come down, touch on this edge here, and then I know how much I need to raise the table by. So another change to the design, this is the location of the bracket on the table. In the original layout I was just relying on close-fitting countersunk screws. For me it's quite difficult to accurately locate holes, so I've come up with another idea, and that is to recess the table so that the bracket actually sits in a sort of recessed area. So this means that the table needs to have a slot cut into it, basically a chord with a fairly precise distance from the edge of the body or the edge of the table, 0.52 inches, and it will leave a little land here. And the idea of that land is that it will locate in the slot to the rear of the bracket like that. And that should then locate this in this direction in terms of its angular position and also across the radius like that. So there's plenty of scope for error here. So rather than just taking it over to the milling machine and relying on my dials, I'm going to scribe a couple of lines on this just as a rough guide to make sure that I am cutting in the right position. I'm just using this to line up on the radius, and then I'll use that to scribe a line. I'll just do a quick visual check on that. That's 0.53, it should be 0.52. I guess that reflects the thickness of the scriber point. And I'm going to do the same for the land that will locate in this slot. More difficult than it looks actually. So this is my setup for milling this slot. This is at the last stage really of working on this table, and a lot of work's gone into it and I really don't want to make a mistake. So I went inside and had a cup of tea and did a bit of arithmetic just to work out the table movements. I thought that would minimize the chance of error. What I'm going to do first is I've touched off on the rear diameter and I have got to traverse across by this amount to cut this side of the land, and then across again to cut the other side, and then I'll touch off on this side of the diameter, move across this way, cut this face, and then the other side of the slot. So these are all my dimensions here in inches and millimeters. And as a other precaution, I'm going to use both the dial and my DTI. But my DTI only has ½ inch of travel, and I need, well, just over ½ inch, and I need just over 1 inch of travel for this first traverse. So I'll be adjusting that. Great, that's the fit I was looking for. Okay, over to the drill. This actually fits in quite nicely, but just to make sure, I put a clamp over the top of it, and it's very slightly up at the back so that it puts most of the load on the front here. So hopefully that will seat it nicely on here. And of course I've got a clamp here with a spacer underneath so I can drill through. At last, the final stage on the table, and this is just to tap it to M5. So the base is complete, the table is complete, the split nuts, obviously the holding down bolts. This isn't quite complete yet. This needs to be fitted and mounted on the lathe to cut this outer radius. But I don't have the socket head cap screws for this yet, so that will have to wait till next video. I do hope you'll join me for that.